each possibility here, there are 8 bits, so maybe that bit is represented by 1, 1, 1, 1, 1, 1, 1, 0. Okay? That's one number. 1, 1, 1, 1, 1, 1, 1, 1. That's a different number. 1, 1, 1, 1, 1, 1, 0, 1. That's a different number. Right? And you can go down through here with all the possible permutations, all the possible options. Right? Different combinations of 1 and 0, 8 different numbers, or 8 different places. Okay? And this is an 8-bit address. 8 bits, 8 bits, 8 bits, 8 bits, which means 32 bits total. Who knows the formula for calculating the total number of possible addresses using 32 bits? How would I represent this? Let's do it a different way. Binary format, if I wanted to represent that, if it was decimal format, let me back up. Binary format, if I wanted to identify this in binary format, I would say a total of 32 bits, so 32 to the how many power? To the second power. That's one way. Now, let's back up. What was the cheating way I showed you to calculate or to convert? Jill?
Just subtract.
Okay, so get me started.
Like, 179 minus 128.
Okay, if I wanted to convert this decimal number, you're on the right track. If I wanted to convert this decimal number to a binary number, what would be the first step? And this is something all of you should do, and I want Jill knows this.
Good one. There's 128 going into 178.
Okay, so I would start with 128, then what would I do, Jill?
Subtract 128. 179 from
Not yet.
Oh.
Let me do let's get the
Oh,
format.
128, 64, 32, 16.
64, 32, 16, 8, 4, 2, 1. Okay? Now, what have I done here? I'll start out with 128. If you can remember that, then if you can just remember 128, then you can do that. What is the little formula I use to get all the rest of these numbers? Look, just look at it. Austin, be quiet. Yes. I cut it in half, or divided by 2 until I was done, right? So 128 divided by 2 is 64, divided by 2 is 32, divided by 2 is 16, and so on and so forth. Down to 1. I can't divide 1 by 2, all right? So now I have how many bits? Or how many places? 1, 2, 3, 4, 5, 6, 7, 8. Each one of these is a placeholder for all the different options of this 8-bit number, okay? So given this number, if I want to translate this, how would I do it, Jill? If I wanted to translate this to binary, what would I do?
Subtract.
Okay, so I've got, I don't give myself enough room, 179 minus
128.
128. What else do I do before I write down the 128? Jill? A 1, because I'm trying to represent this in decimal and binary format. So if I can put a 128, if 128 goes into 179, then I put a 1. That's 1 and 5. Okay? Taylor, next step. Okay? So I put a 0 here. Since 64 will not go into 51, right? Now what? Zach.
You try 32.
Okay, and what do I end up with? No, what's the next? I did 64. 64 does not go into 51, so I put a 0. Does 32 go into 51?
Yeah.
Zach? Okay, so what do I do?
You divide it.
No, don't divide.
Okay.
Correct. So if I know that 32 will go into 51 at least once, then I put what over here?
On 1.
Correct. Okay, so now that's 32. Now what's that?
16?
I don't know. What do I do with this number over here?
Oh, it's subtracted? Right?
Yes. So that's 9, 4 minus 3 is 1. Next, Zach.
3 by 16?
Yep, does it?
No.
16 and 19. Is 16 less than 19? That's the question we want to ask.
Oh, yeah.
Yes, so since it is, what do I put?
1.
Correct? So I put 16. Zach, keep going with this. You're on a roll, buddy.
Okay, so then 8 is going to 3, so
8 is not less than 3, so I put what?
0?
I put a 0. Okay? I don't subtract anything. I look at this 4. It's the next number. Now what? Is 4 less than 3?
No.
It is not, so what do I do?
0?
0. Is 2 less than 3?
Yeah.
Even or less than 3? It is, so I put a 1, correct?
Yeah.
Then what?
What do you mean? Oh, you subtract.
And that leaves 1. Is 1, is it equal to or less than 1?
Equal to?
Yes, so what do I put?
1.
Okay, so this is the binary equivalent of this decimal number. This is the binary equivalent of this decimal number. Everybody got that? All right, we'll do one example of this again from the very beginning. From the very beginning. Who is hiding? No. Come up here. Come on up here. Yeah.
Me? All right, you want me up there?
I want you up here.
All right.
I have an IP version 4 address of 193.99.174.6. I just want you to convert that first octet. What? What the that one's?
It's always off. We're 4 minutes cool.
All right. So, outstanding. Big round of applause. Very simple. Start out with that 128, and you know what to put down below it. You have it each time. Is 128 equal to or less than 193? Yes, you put a 1 there for the placeholder. Now we're going to go the other direction. We're going to convert from binary to decimal. And of course, you would do that with each one of these. Okay, so 99. Jordan, you're up. Yes. Good. You're going to start here. Let me make a suggestion. Start out with 99 over there, because that's what you're converting from decimal to binary. So erase that. Start out with 99. And then forget this column. We're starting with the 128. Follow the formula we just went through. Is 128 equal to or less than 99? Okay? Okay. That's it. Very good. Big round of applause. All right, guys, anyone, honestly, tell the truth. I won't make you get up here. I'll just go over it again. Is anyone unsure of how to do this? No one is unsure. Truly. Okay? All right, so now what we're going to do is we're going to convert from binary to decimal. Very simple. Very, 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 very easy to do. It's more easily done than converting decimal to binary. What do you think the first step is? Who thinks they know the first step? Quentin? So I have, okay, I'm sorry, let me start you out. I've got 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay? So, dot, 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 dot. Quentin, you're up. What do you think the first step is? I need to convert that to binary. Or, I'm sorry, to decimal. You know the first step? What was the first step in the other process? Okay, now 128, 64, 32, 16, 8, 4, 2, 1. Think about this. What did each of those represent? Bits. Don't talk. Bits. Okay? So, if this 1 is a bit, it represents what part in your binary, in your decimal chart. Okay? That's on. What's this one represent? What's this one represent? Okay? So, start out the exact same way. Put your chart up there. That's one way. It's a long way of doing it, but it's an easy way. Come on up here, son.
Okay.
If each one of these is a placeholder for those numbers, first of all, define the numbers, decimal numbers. Just write your little chart out. Okay, so now, if this represents the 128 placeholder, this represents the 64, what do you think a logical thing would be to come up with the ultimate decimal number, or the final decimal number? Add them together. There you go. So get over on the right side and start adding the ones that make sense. Okay, so for those who were watching on video and in the back of the room, he added 128 and 64. Explain to him why you added 128 and 64.
Because these two were equal ones, so.
Okay? All right, so the next step would be adding what? To what? Yep. Okay, so 192 plus 24 is 216, plus 3 is 219. Okay? Anybody disagree with that? So it's actually a little bit easier so you don't get confused. It's easier for me anyway. Go ahead, have a seat. So if I put these ones next to it, 1, 1, 0, 1, 1, 0, 1, 1. Now I know that I have to add 128 plus 64 plus 16 plus 8 plus 2 plus 1. 12, 18, 26, 28, 29. 2, 4, 10, 11. 2. 219. Okay? If I add all ones, how much does this add up to? If this were all ones, what would it add up to? Yes. 255. So I know it's going to be 1 up to 255. 1 up to 255. Those are the only options we have. Okay? So, start out 128, 192, 224, 240, 248, 252, 254, 255. You add all these up. And what you'll find is as you get used to these numbers, you just add them up. You know that 128 and 64 is 192 because it's a very common number. All right, let's try one together. Or I'm sorry, not together. Let's do it up here. Josh Everly, come on down. You're on The Price is Right. I want you to do this second one. Here you go. Okay, tell them what you just did. They can't see it in the back or on the screen.
I wrote down the chart.
You just started 128, halved it until it got to 1. Now what are you doing, Josh? Find out which ones have placeholders, which ones do not. Okay? Now what are you doing, Josh?
I'm adding all up.
Adding up which ones? All of them? That'd be 255, right? Okay? Then what? Ah ha ha! There you go. I was wondering when somebody would come up with that. So if all of these are 1s, and this placeholder represents 1, 2, 3, 4, 1, 2, 3, 4, the 0, it'd be just 255 minus whatever this was, is 8. Make sense? Everybody follow that? In this one, what's this? Somebody raise your hand. Tell me what this number is. Yes?
254.
Very good. 254. Okay, 254. You get the idea, right? If everything is 255, and you only have a couple, so in this particular one, it'd be 255 minus the fourth one, which is 16. Help me. 239. Yes?
Sure.
239 minus 2, 237. So there are lots of shortcuts, but if you understand this first, then you can do it. Now, here's the key. There's a binary calculator on your computers. I'm going to just tell you that if you didn't know it already. And you can convert them using the binary calculator. However, you don't want to do that. You want to do it manually, so that you understand the process for doing it manually. Because when we start looking at subnets, you need to understand why bits are where they are. What?
I'm not mess around with binary calculator and put online and put me for words binary. We weren't going to do that.
No. No. Okay? Everybody understand? Everybody understand? Okay, so here's what I want you to do. Get out a piece of paper or get on your computer, I don't care which. Doesn't matter, whichever's easiest. Okay, on your own, not with a partner. I want you to convert the following IP address to binary format. 192.168.231.75. Okay? 192.168.231.75. And then I want you to leave it up so that I can see it. Without using the binary calculator.
Jeez, I guess I'm cheating. My mind is binary calculator.
What? Yes. Is it equal to or less than?
If it's equal, then we just leave it alone, just keep going, or you actually subtract stuff.
I don't care about your work, Aaron.
You want to see it?
I want to see it. Bring it.
I'm done.
That's great. Just hold tight. All right. Well, that's just the first number. I want the whole idea. Oh, okay, I got you. I'm sorry. I have to write it out. Joshua, what are you? Are you done? All right. Oh, it is 75. That's a check. My suggestion?
No,
Do it on paper.
I'm sorry.
I'm not going to check everybody's. I just want to do a quick spot check. Yep. All right. Just hold tight. Hold tight. $192. Again, the more often you do this, everybody done, by the way? Some of you are doing it a little backwards and you can get confused pretty quickly. I just watched how you were doing it. 192, that one, okay, let's go back to our chart. 128, 64, 32, 16, 8, 4, 2, 1. Okay, how many bits? 1, 2, 3, 4, 5, 6, 7, 8. Now here's an easy way of doing this. Okay, 192 minus 128, yes, equals what? 192 minus 128 is 64, so you know the rest of these are zeros. Okay, 128, yes. You know that 64, because if 64, 128 equals 192, you know that's not going to work. Best bet is start over here, 168 minus 128 is 0, 40. Now, real quick, right? Which of these add up to 40? 1, 1, right? Follow what I did? 32 and 8 equals 40. That's easy. 231, you know that's it, you know that's it. So that equals 192. So 192, or I'm sorry, 231 minus 192, 39, right? Yes, no, no, yes, yes. What did I lose track? 1, 2, 3, 4, 5, 6, 7, no. One count. That can't be right. Let's do it the right way. 128, 192, 224. Okay? 231 minus 224, 11 minus 2 is 9. How do you get 9? 8 plus 1. Right? Am I right? $128, $192, $224. Ah, this one's off, right? One, two, three, 4. Is 8 on or off? Huh? And I did it wrong. 4, 6, 7. So you guys came up with 7 at the end. Did I subtract that wrong? All right. 75, no, yes. 75 minus 64 is what, 11?
12.
So 0, 0, 1, 0, 1, 1. Okay, is that what you had? And then the easiest way to do it, to check it, is just to go back and add it up. 128, 192. Yep, 192. 128 plus 32 is what?
160.
Is 160. Plus 8 is 168. That's correct. 128, 192, 224. Right? 231 minus 224 is what? 231 minus 224. 7? 6, 7. Okay? 75, so that's 0, yes. 64, 75 minus 64 is 11. So 64 plus 8 is 72, 74, 75. All right? You guys are geniuses. Austin, what's your question?
Oh, I was
You were what?
It was a comment about if we were going to get something from happening this way.
You said you had a question.
Yeah, it's a question and a comment.
All right, get to it.
Okay, so are we gonna ever have any kind of assignments where we have to like do this
Yes.
and then check on it? I was gonna say, the easy way to check our work against yours is just to look at the last digit. Because if it's wrong, somewhere in there it's gonna end with a different digit.
Thank you for the shortcut. It'll be on the test. We'll have tests that you have to do this for. Okay? Everybody understand this? Anyone not understand this? Please. Please, please, tell me now. All right, we're going to go the other way. We're going to convert from binary to decimal. You what? Probably going to have to get out a piece of paper for this. Here's what I suggest that you do. Create 4 columns. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I want the decimal equivalents. I'm going down here. Each one of these is an octet. First octet, second octet, third octet, fourth octet. You're done. Turn that off, please.